Howdy again, that's Mr. Pete. Welcome back to the shop, and I'm continuing with my UNIMAT series here. And if you watched the recent video where I made these tiny little brass hex head screws, you might have enjoyed that, and you remember how I went about threading those, not under power, and I do not have the attachment to do single point threading on here, and I probably wouldn't want to do that anyway, but I used this die stock in order to do that, and I cut off the handles because it was way too big and cloddy. But the idea here is I push this die with the tailstock into the work and rotated and was able to get a straight thread. But this is kind of awkward, and I decided to make a die holder like this. This is my prototype, and it would hold these 5/8 diameter button dies and will fit 7mm shank into the tailstock. And there'll also be holes in there so I can hold it with the Tommy bar. And that is what today's project is all about. So let's begin. Well, on my larger lathes, I have all kinds of die holders that go into the tailstock and hold a die of different sizes. Here's one that holds the 1-inch common die that I might use on the Atlas lathe, and that's a power operation. I'm doing the threading under power. Now, it will not be done under power here. I just need a way to hold the dies, so I'm going to take some of these tiny dies that I have. These are 5/8 in diameter, and make a little die holder like this. And this is my dress rehearsal sample. So the die would go in as such. These would be smaller dies, 540, 6, 440, and so on. And this would slip. This is metric. I forgot how many millimeters, and it would slip right into the tailstock like that. And this, by the way, this isn't quite finished. And I would move the tailstock up toward the headstock, and I would hold this still. It won't take much to hold it on brass with small sizes, and rotate the spindle by hand. So that's what I'm going to do in this video. Make another one of these with some modifications. And this one isn't quite done. As I said, there needs to be a set screw in here to hold the die in place. So that's today's job. That was a long introduction. Let's go on over to the bench. As I said earlier, in order to make this 5/8 hole, if you do not have a counter bore, which I'm going to use, you will have to use a boring bar, and that would work just fine. But that's not the way I'm going to do it. I was lucky enough to have a 5/8 counter bore, 5/8 diameter here. The pilot is 3/8 diameter. Now, let me explain something else here. Since this is a relatively shallow hole here, I cannot use the original pilot in the counter bore, which is this, because it wouldn't allow me to go in deep enough. So I took the counter bore out, the pilot out of the counter bore, and it's held in there by a set screw on the flat. And I made a new pilot that is much smaller, as you can see, but I wasted almost an hour doing that, so you're better off with this. But I'm going to finish this way. Again, it will allow me to get in there just the right depth. So the first thing I'm going to do is center drill, and drill that 5/32 all the way through, and then a 3/8 hole of a certain depth. I forgot what it is. So let's go on over to the closing, and yes, I am using the closing to do that. We certainly couldn't use a counter bore this size over there on the UNIMAT lathe, so maybe I'm cheating a little bit. Now the diameter right here is 7mm, but in thousandths it comes out to 283 thousandths right here. So I was doing an inventory here on these smaller dies, like I just mentioned. They're 5/8 diameter, 5/8 OD, as opposed to the larger ones you most typically see that are 1-inch. So you see there is quite a bit of difference, and I'm trying to scale everything down for the UNIMAT. That's part of the purpose here. So these would work, of course, but look at how tiny these are. Also, these little acorn dies will fit in this holder that I'm going to make, should I ever want to use one of those. Now I have a little sketch that I made, and I've already made changes from this. I don't want you to go by that if you would happen to make something like this in whatever size, but this is the original one that I made, and it's fine. It's a little sloppy right here, so I'm going to redo it, but I'm using larger stock, that is 1-inch stock. That gives me a little bit thicker wall here to put the set screw in, so I have plenty of engagement. So I'm starting with 1-inch stock, but I had turned this one down to 900 thousandths. If it's out of proportion or out of scale when I'm done, I will take a little bit off. But for now, that's how I'm going to do it. And if you look at this now, again, I used the counter bore for that. Now there'll be a smaller hole that goes all the way through as well, about 5/32 or whatever you want to make it, so that if you're threading a long piece, it has some place to go. That's the purpose of that hole. You don't have to do that if you're doing short threads. So this is 1-inch diameter 12L14 free machining steel. Now you can hold this or machine it in two different ways. You could machine it, well, let's say from this end first, and that's the way I made this one. I turned down the shank and then I reversed it like this to finish off. In this case, I'm going to do just the opposite. I'm going to machine the large bore and then turn it around like this and turn the shank down to, what did I say, 7 millimeters? Some operations will be sped up here, but I've already faced the end, center drilled it, and now I'm drilling 5/32 diameter, 1 1/4 deep. And now 3/8 drill, 1/2 inch deep. I need to have a flat bottom hole, so I do not have a 3/8 bottoming drill, so I'm using a 3/8 end mill, and I'm just squaring up the bottom of the hole. The counter bore is mounted in the tailstock chuck. Now these dies are exactly 250 thousandths thick, so that's how deep I want to counter bore. Alright, I'm just the right depth. I had to take a little bit more off, to be honest with you, so I went a little bit deeper, and I checked it with my caliper here, and I'm 252 thousandths, which is excellent. And taking a die, stick it in there, and it's perfectly flush, so I'm done with this side. I want the overall length to be 1 1/4 inches, so I'm going to cut it off just a little bit over 1 1/4 so I can face the end, and then I will turn it around and we will machine the shank from this side. I want the shank to be 5/8 long, so I've laid it out as you can see there, and I'm ready to turn down the diameter right here to 7 millimeters. Well, that turned out perfectly. This is exactly 7 millimeters. Now I need a little set screw, 632, to hold the die in place, because remember, on every little button die there's a dimple. So I arbitrarily and capriciously decided on a 632. It's already laid out 1/8 inch from the bottom with the height gauge, and I will drill and tap that routine hole off camera. Are we having fun? Is everybody happy? Okay, that turned out real nice. There's the set screw, 632. Now you may have noticed that I made this one wider or thicker than the original. Why so? Because remember, this is not power, not to be used with power threading. I will have to hold this with these Tommy bars. Now the Tommy bars are the little bars that I use to tighten the chucks on the 3-jaw chuck on the UNIMAT. So I will, the reason this is thicker now is because I need space for that hole, which will go all the way through. I've already got it marked so that I can literally hold or turn this in the tailstock. Did I say this needs to be drilled number 19? And I'm going to do that in the milling machine because I want it very accurate. I want it to go all the way through, and I wanted it to miss the counter bore, and that's the reason for the extra thickness here. Well, I wasn't going to show this, but I've got it all set up using center finders, edge finders, all of that, and that's the number 19 drill, and I already did peck on it a little bit, so I'm ready to go. Well, that's perf. So there's the hole. It goes all the way through, and it fits the Tommy bar. So let me clean this up, and the project is done. Now, if I was in the mood, I could reduce the diameter of this a little bit like this sample, but I'm done. Let's put it up, let's go put it in the UNIMAT and see what happens. Well, the project is essentially done. By the way, if you like my videos, I have 1,500 more of them for you to watch. Please subscribe if you're in the mood. So here it is, and I have mounted a 1024 die in there, and I think that's the very biggest thread that you would ever do on a UNIMAT. Maybe it's a little bit overkill, but you can see that the die is held in there by the little set screw, and I got the Tommy hole marks. So the 7mm shank fits freely in the tailstock, and it is able to spin. Now I put a 1024 screw in there just as a mock-up to show you how this works. Remember again that it's essentially a hand operation, so I would probably, I've got my hand on the pulley here, if this was brass, let's say, and now of course this is going to spin, so the Tommy bar would be used to hold it still. And to get the thread started, of course, this tailstock can be locked, and we can force it in a little bit. But once it's engaged, we're free just to thread this way. And if the going gets tough, the other Tommy bar can be put into the chuck like this to keep it from turning, to get it started. So do you understand what this is for and how it is to be used as compared to me power threading in the, say, the Atlas or the closing lathe using this 1-inch die holder? Pretty slick. Well, that concludes this video. Thanks for watching. This is Mr. Pete saying so long for now, and I'll see you next time.